Hi class. In this lecture, I want to talk about a more commonly used form of interest that you might get from your bank or in financial institutions in general. And this form of interest is what we call compound interest. The formula looks a little bit like the simple interest formula, but there's some key differences to it. And we'll work a bunch of examples so you'll get to see. All right, so we have the three objectives in this section. The first is we want to use the compound interest formula. I'll give you those. We want to calculate present value. So how much of future loans value is worth in today's dollars. And then we want to understand and compute what we call the effective annual yield of a loan or of interest. Okay, so compound interest is interest computed on the original principal as well as any accumulated interest. So think of compound interest as interest on top of interest. Okay. So to calculate the compound interest rate, now this is when interest is paid only once a year, okay? So once a year. So A is what we call the account's future value, so how much money you'll have in the account, is equal to the principal P, okay, which is the present value of the account or just how much you've deposited in it, times 1 plus R, and R is the rate of the loan or rate of interest, so like interest is 6% or something, that would be 0.06. And then you take 1 plus R and you raise that to the number of years. Like if you're going to leave it, the money in the account for like 5 years. Just remember when you do these problems, the order of operations. So you do parentheses first, then the exponent, and then you multiply it by the principal. Just be sure of that. Careful of that too. All right, let's do an example. So you deposit $2,000 in a savings account at Hometown Bank, which has a rate of 6%. All right, so here's what I want to do. I want to find the amount A of money in the account after 3 years when it's subject to compound interest, and I want to find the interest. All right, so when it just says compound interest, what that means is it's just compounded yearly. Okay, if it's compounded monthly, which we'll do an example of that later, it's going to be noted. Okay, so if it's just compound interest, or it might say something like compounded annually, that just means it's once a year. All right, so the principal, P, all right, is $2,000. The rate from above is 6%, so we change that to 0.06. And T is the number of years, okay, and that's 3 years. So substituting this into the compound interest formula, we get the future value of the loan is equal to the principal, which is 2,000, times 1 plus the rate, so 1 plus 0.06 raised to the third power. Well, you plug this into your calculator, and I will do that with you so you can see. You would take 2,000 times, and then in parentheses, 1 plus 0.06, close the parentheses. Now raise that to the third power. And how much money you would have in the loan, okay, after 3 years would be $2,382, yep, and rounded to the nearest cent or 3 cents. All right, let's do the next one. Let's find the interest. So to find the interest, it's the amount in the account after 3 years, but you subtract away the principal, so how much you initially deposited. So if this is how much I have in the account after 3 years, but I started with $2,000 in the account, I made $382.03 of interest. Okay, that's pretty good for leaving your money in the bank for 3 years. Just to know, in the real world, banks don't give 6% interest on interest accounts. This is just to make things easier. It's actually a lot less. So this would actually be really good. Okay. So let's change it around a little bit. Let's talk about when things are compounded more than just annually or yearly. So if you deposit P dollars at a rate R, okay, and this is in decimal form, subject to compound interest paid N times per year. So usually banks deposit money into your account, interest in your account every at the end of every month. Okay, so let's just say it's compounded monthly or 12 times per year. Then the amount A of money in the account after T years is given by the following. So A is the account's future value is equal to the principal, all right, times 1 plus you take the rate and you divide it by the number of times you're compounding it. and then you raise that to the number of times you're compounding per year times the number of years. Okay, so this right here is the compound interest formula, but modified a little bit so that it can be compounded more than just once a year. Now let's do an example. So suppose you deposit $7,500 in a savings account that has a monthly rate again of 6%, all right, and it's telling you the interest is compounded monthly. Okay, so again, how much money will you have in the account after 5 years? And let's find the interest after 5 years. All right, so solution. The principal, again, that you deposited is $7,500. The rate is 6%, so that's going to be my R. T is the number of years. Well, I have had it deposited for 5 years. And N is 12 because it's compounded monthly for the 12 times per year. All right, so substituting this into the principal interest formula. Okay, I'm going to show you how to do this in your calculator again. So you're going to take the rate, or excuse me, you're going to take the principal, which is $7,500. You're going to multiply it. Now in parentheses, you're going to take 1 plus 0.06 divided by 12, okay? And you're going to raise that to, now you have to put this in parentheses. Okay? You're going to raise this to the 12 times 5, and then close the parentheses. And look, after 5 years, you will have $10,116, and when I round this, I have 38 cents. That's really good. Let's find out now how much you have in interest after 5 years. Well, again, this is the total amount in your account. Subtract away the principal that you initially started with. And after 5 years of leaving your money in the account, if it's getting 6% compounded monthly, you would have made $2,616.38 in interest. Not too bad. Okay, some banks, instead of doing it monthly, use what's called continuous compounding, right, where the compounding periods increase indefinitely. All right, so after T years, the balance A in the account with principal P and annual interest rate R in decimal form is given by the following formulas, okay? So if N is compounding N periods during the year, so like it's compounded quarterly, annually, monthly, you use A is equal to P, and then in parentheses 1 plus R divided by N to the N times T. But if you use continuous compounding, okay, so interest is continuously, nonstop, indefinitely working interest on interest on interest, you would use this formula. The amount A is equal to P times the number E, and I'll show you what that is in your calculator, raised to the R times T, so the rate times the number of years that you have the loan in for, or the money in the bank. All right, so P times E raised to the RT. All right, let's do an example. So you decide to invest $8,000 for 6 years, and you have a choice between 2 accounts. All right, the first pays 7% per year compounded monthly, and the second pays 6.85% per year compounded continuously. Okay, which is the better investment? Okay, so first off, the better investment is the one with the greater balance at the end of 6 years, obviously. So using your calculator, all right, let's do the compounded monthly first. So the amount in the account is equal to the principal times 1 plus R divided by N raised to the N times T. Well, that's the $8,000 times 1 plus, well, if it's compounded monthly, it's getting 7% per year. So 0.07 divided by the 12 months, close the parentheses, raised to the 12 months times the 6 years. And after 6 years, this account getting 7% compounded monthly, we'd have $12,160.84. Okay, that's really good. So keep that in mind. So compounded continuously. All right, let's figure out how they got this. So the amount principal is equal to 8,000 times, and then on your calculator, you see this little button, the LN button in Right here, you see this e to the x. You would press second function, e to the x, and it would raise e to the x. Well, the formula was the rate, 0.0685 is what they were offering, times the number of years, so 6%, close the parentheses. And that account would have $12,066.60. So the investment done at 7% actually compounded monthly has the higher rate or higher amount at the end of it. So that's actually better. But you can actually see if they were to offer 7% compounded continuously, that would actually be better. And so you could see the subtle difference. This would have $12,175. This would have $12,160. But they weren't off. They were offering a lower rate to have it compounded continuously. All right. So I want to talk now about calculating the present value of a loan. So, or present value of money in a bank. So if A dollars are to be accumulated in T years in an account that pays R compounded N times per year, then the present value, okay, so how much the value of the account is in today's dollars that needs to be invested is given by the following. Well, the present value is equal to the future value that you want to have in the account, A, divided by this 1 plus R divided by N raised to the N times T power. Right? So basically, if you think about it, you were just taking this and dividing it over to the A side. All right, let's do an example. So how much money should be deposited into account? So how much money is present value today? All right, do an account, and I'm telling you that it earns 6% compounded monthly, so that you will have $20,000 at the end of 5 years. All right. Well, so just use this present value formula. So the amount of money you want to have in your account is $20,000. You know you're getting 6% interest. You know that N is compounded monthly, so that N is there is 12. And that the number of years you want to have this total money in is in 5 years. So you take the amount you want to have, 20,000. You divide it by 1 plus the rate divided by the number of times compounded, which is 12. That raised to the number of times compounded N times number of years T. And let me show you how they got this number in your calculator. So you have to be very careful here when you do this, okay? So you're going to take 20,000 that you want to have. You're going to divide that by, now in parentheses, you're going to take 1 plus 0.06 divided by 12, close that parentheses, raise that in another parentheses, 12 times 5, close that parentheses, and you got this $14,827.45. We'll have to round this one up, or always when you do these problems. So if you want to have $20,000 in 5 years, okay, then this we would need to have deposited $14,827.45. So just straight up following the formula and plugging it right into your calculator. All right, our last topic. So the effective annual yield, or the effective rate, right, is just what we call the simple interest rate that produces the same amount of money in account at the end of 1 year as when the account is subjected to compounded rate interest at a standard rate. All right, so let me give you an example of this. So you deposit $4,000 in your account, and that account pays 8% interest compounded monthly. So let's find the future value after 1 year, and then let's use this future value formula for simple interest to determine the effective annual yield. All right, so the first thing you do is you find out how much money you're going to have after this is compounded monthly. So you take your $4,000 principal, multiply it by 1 plus the rate was 0.08, divided by the 12 months of the year, raised to the 12 times 1, right, number of times the number of years. So at the end of 1 year, if it was compounded monthly, you would have $4,332.00. Okay, so how do you figure out what the annual yield was? Okay, so how much interest you would earn if this was just simple interest? Well, The effective annual yield is a simple interest rate. So we use the future value formula for simple interest to determine R. Well, we know at the end of the year, you were going to have $4,332 from here. That's equal to your principal times 1 plus R times T. Well, T here is 1 year. So basically what you're doing is you're distributing the 4,000 to each term. All right, so you get 4,000 plus 4,000 times R. Subtract the 4,000 over. So look, at the end of the year, this is what it's saying. You basically made $332 in interest. Well, if you divide that by the principal, the 4,000, okay, the simple interest, so your interest, the effective annual yield, how much you really earned by the end of 1 year, it ended up being 8.3%. So this compounded monthly, the number of times you compounded as that increases, it makes the annual effective yield actually higher than the stated rate. All right, class, thanks for watching the lecture.